Yes, that's good. Thanks, Miss Winnick. We're ready to roll here, baby. We're talking about some geometric probability. You know how we do it. Make this a little bit bigger. Oh, I'm on the pen tool. There we go. Okay. Geometric probability, the chance of being in the shaded region. So it's similar to what you've learned about probability before, but now we're in the geometric world, so we're talking about area. And this is the key to everything, shaded over total. So we look at this first scenario here. Sometimes you're given the dimensions and sometimes you aren't. So in this case, I've got a 6x6 square that has a circle inscribed in it. And when I'm thinking shaded over total, this is always my game plan, of course. Shaded over total. So the shaded is going to come from, how do you find the shaded area? Well, you have to take the squares area and subtract the circle. And then the total is the square. So all the way around, okay, like that. All right, so now just plug in. So the squares area is 36. The circle's area is pi. The radius, of course, is 3. So pi 3 squared. And then the total, again, is 36. So now clean this up. When I clean this up, let me see, I'd have 36 minus 9 pi over 36. Algebra skills here. What can I take out of every term? A 9. So that's 4 minus pi over 4. So 4 minus pi over 4 is your SAT answer. All right. Now, how can they not give you dimensions sometimes? What are you talking about, Mr. Stans? What are you talking about? Like, they won't give you dimensions? Because it doesn't matter. I can make up whatever I want, and I'm going to get the same amount of area occupied by this circle inside a square, as long as it's directly inscribed like this, where it's touching all the way around. So here's what I mean. So you can, when I say you can make up your own, it could be a 2 by 2. If it's a 2 by 2, then the radius is 1. And so it's still the same game plan, square minus circle over square. Square is 4. Circle is pi 1 squared. And total is 4. So you can see how that is the same thing, guys. So 4 minus pi over 4. Isn't that sweet? So the SAT sometimes will leave it blank, like this one, and just be like, hey guys, what is the chances of you selecting a point at random inside this figure that would hit this shaded region? All right, and that's how you would do it. So you're thinking probability that you might want a numerical answer, or a decimal answer, I should say, but it doesn't always have to be. Woo. Moving along. What about this? We can get crazy, people. What if I have 4 circles busted up, touching each other, no dimensions? So let's pick something. I'm going to pick something that's divisible by 4, because all the way across, these 2 diameters are each 2. So then each radii is 1. Each radius is 1. So, same thing, guys. Let's see. Shaded over total. Shaded over total. So the shaded now is going to come from the square minus, I'm trying to get in these shaded regions, this shaded region. So now I'm subtracting the 4 circles. And the total, again, is the square, the whole entire thing. So the squares area in this one, I've got a 4 by 4 minus 4 circles. So each circle is pi 1 squared, and then the total is 4 by 4. So this cleans up into 16 minus 4 pi over 16. And guess what that reduces to? You guessed it, 4 minus pi over 4, once you take out a 4 of every term. All right? Isn't that cool? So whether you have 1 circle or 4 little circles, what if like this one, the circles got cut in half and are facing the opposite way? Guess what it's going to be? Woo! So that's pretty neat. Wanted you guys to take a look at that. All right, now dartboard problems, these can get a little crazy, but watch how we're going to attack this. So the question we posed, like, all right, so I have to stay within this circular board. I'm throwing a dart at random. If it goes off of this circle, it doesn't count. So it's hitting this board somewhere. What's the probability of each of these things happening, each of these rings? So first, let's do the bullseye. Our process is still shaded over total. So the shaded now is the bullseye. All right, well, the bullseye's area is pi 2 squared, pi r squared. And the total is, let's see, we got 2, 4, 6, 8, 10. So that's pi 10 squared. So I got 4 pi's over 100 pi's. And my pi's will cross out. So you got 4 over 100. You got about a 4% chance of hitting the bullseye. All right, not very good. How about the second ring? The second ring, right? Well, now you come out pi 4 squared, and that's this ring. But now look what you have to do. Pi 4 squared takes you all the way out to here, but then you have to subtract out the inner circle so that you're just left in that ring. So then that's minus the inner bullseye. So that's minus pi 2 squared. And the total is still pi 10 squared, the whole thing. So now you've got 16 pi minus 4 pi. So that's 12 pi's over 100 pi's. Pi's cross out, 12%. So the bullseye was 4%. The second ring was 12%. Here I go now with this third ring. So I got to come out 2, 4, 6. So pi 6 squared. Now you subtract out all of this now too, because you just want to be left with what's in the third ring. So that is pi 4 squared, what you just had before that. And the total is still pi 10 squared. So I've got 36 minus 16 is 20 pi's over 100 pi's. Pi's cross out, 20%. And you might see the little pattern that exists here. You're going up 8, up 8. So you can get the rest of the rings just by doing that same thing. This ring would then be 28% chance. And the outer ring, of course, would occupy the most area, would be a 36% chance. So there's a bullseye problem. Shaded over total, whatever ring that you're looking for. Sometimes you got to do a little bit of work and subtract. The bullseye, you don't have to subtract anything. It's just the inner circle. And the total is always the entire dartboard. All right, final problem from our notes. We've got, what's the probability that a point shows at random is circle O is not in sector AOB. So now we want it to be in all this other stuff. All right. So a couple ways you can attack it. To find the area of this shaded region, because again, your game plan is shaded over total. So that's the probability. The total is easy. It's just the big circle, pi 5 squared. The shaded region, you got to do a little bit of work at least, again. And of course, you know, like I said, there's a couple ways you can attack this one. If you attack it like just by taking 360 minus 72, then this angle is 288 degrees. So you could say the shaded area is 288 3/60ths of pi 5 squared. All right. And of course, that is just, when you reduce that, that's just 5/6. So, I'm sorry, 4/5. So this is just 4/5 of is times 25 pi all over 25 pi. Now it's just algebraically simplifying. You can reduce this, the 5 and the 25, multiply straight across, and you got 20 pi's over 25 pi's. Pi's cross out. And of course, the chances that you would be in the shaded region, you got 4/5 or an 80% chance. And that's a wrap, people. Peace.